perfSONAR is a tool that's used to measure end-to-end performance. And a question that we often get asked is, where should we position our perfSONAR node on the network? If, for example, you've implemented a Science DMZ on your campus, it makes the most sense to place a perfSONAR node next to the Science DMZ resources. This helps you get a good indication of what the performance is going to look like end-to-end between the Science DMZ and remote collaborators. If your site doesn't have a Science DMZ, it makes the most sense to position the perfSONAR resource where the rest of your science equipment is located, perhaps behind an enterprise firewall. Because perfSONAR is an accurate tool for measuring these different use cases, let's look at some examples of what performance may look like behind your enterprise firewall versus what you may see within your Science DMZ. In the first example, we're going to look at performance to this resource right here located on our network map, which is located in our enterprise network behind an enterprise firewall. If we look at a perfSONAR graph, which was created by initiating regular end-to-end tests, we notice a couple of things. The first example that we see here is this blue line. This is the performance that we notice when we are testing outbound from our node that's located within our campus resource to something that's very far away. We see that performance is reasonably high with some degradations due to congestion or lack of buffering. This is normal. If we look at the second example represented on this graph, represented by the green line, we see that inbound performance, when something outside is trying to send in through our enterprise firewall, performance is much lower. In some cases, lower than 100 megabits per second. There are many reasons why this could be, and to figure this out, we need to dig a little bit deeper into the output of the tool. Looking at the output of this tool, we see two pieces of information that are valuable. The first column that we see is the actual raw performance. This backs up the numbers that we see in our graph that we've plotted over time. Very low performance. The reason for this is related to the second column on the right-hand side. This is the number of retransmissions that we see. Retransmissions are an indication that TCP is not able to perform to its maximum capability. Whenever we see retransmissions in any of these tools, we need to investigate further. We can look further at the performance of TCP by using a Tcp trace, and in this case, plotting the output of this. If we look at the graph on the left-hand side, we see that there are many incidents that occur for a 10-second transfer. If we zoom in on any of these little incidents, we see a couple of pieces of behavior that are macro to TCP. For example, we can see that there is a retransmission of the entire window as well as some selective acknowledgments. This indicates that TCP is having a hard time keeping up, and there may be something impacting its performance. To compare this, we want to look at performance to a node that is not located on the enterprise network. In this case, we're going to be performing tests between our provider perfSONAR node and the instance that's located in our Science DMZ. The regular testing data for this shows a completely different story. Performance is high in both directions, and we don't see any of the degradation in performance that we saw with our enterprise use case. Looking at the output of the tool, we see 0 retransmissions have occurred as well, indicating that there is nothing in the path that is going to be impacting our performance. Tcp Trace backs this up as well, and we don't see any of the behavior that we noticed in the first use case. We've already looked at an example of what the performance looks like when we're using perfSONAR to test an enterprise firewall. We'd like to illustrate a second example that shows a slightly different use case, but still illustrates that performance outside of the firewall and inside of the firewall can be drastically different. And a tool like perfSONAR can help us characterize this and fix the problem. This is our network diagram where we have a perfSONAR node that's located within our enterprise network, and we also have another that's located in the Science DMZ enclave. We're going to look at the performance first between the provider and the end user node that's located within the enterprise network behind the firewall. As you'll recall from the previous example, we noted that retransmissions are often indicative of a problem on the network. This isn't always the case, though. If we look at the output of this tool, we notice that performance is still very, very low, but there's no retransmission showing up in the output of the tool. This means that there may be a different problem that's impacting our performance. Tcp Window Scaling is an option that's been implemented inside of operating system kernels for a number of years. And this option enables us to utilize the network a lot better than if we just had a fixed size TCP buffer. What essentially happens is that the TCP buffer is able to grow over time as the algorithm is able to determine if there is or is not congestion impacting the network performance. If we look at the chart below, we notice that a fixed TCP buffer severely limits our ability to perform well.